So this is the real beam that we identified, which can link to the topic of Mohr's circle of stresses.
First, we need to find a loading that acting on a beam which considering the dead and live loads based on Euro codes. So here is an example for the calculation of dead loads that we are able to identify. And this is the summation of the loads that acting along the beam. Next, we find the support reactions. It can be calculated by using the equation of equilibrium. And determine shear and moment functions from the shear and moment diagrams. As we can see here, are the example of the shear force diagram and bending moment diagram. The obtained shear and moment from the previous analysis, we can substitute into several formulas. There are two formulas. 1, flexure formula, and 2, shear formula. And finally, we can do the Mohr's circle. This is the idea for a flexure formula. Meanwhile, this is the idea for shear formula. Next, we go to the sample analysis. From the obtained shear force from the previous calculation, we can find the important components by substitute into shear formula, while the moment, we substitute into flexure formula as shown. Hence, we get to determine the two normal stresses and one shear stress component as we discussed in fundamental earlier. And finally, this is the idea for Mohr's circle. To construct Mohr's circle, first we need to identify 2 points, which are point C and A. Where C, the center we obtain from the average normal stress, X and Y, and A, from the normal stress with respect to X and shear stress. And here is the result of Mohr's circle for a beam structure. And this is the general equations, to prove that the data obtained from Mohr's circle are the same as the general equations of plane stress transformation. In the end, I hope you guys understand how the real structure can link to the Mohr's circle of stresses. I hope you guys enjoy the watching. See you again, thank you.